I am on page 205 at example 2, and I copied this problem from the textbook off screen so you wouldn't have to watch me do that. If you need to pause your video and write this down, by all means do so. But they want us to graph a real world situation. And for me personally, these were always much easier because it was real world. It was something that I could relate to and that made sense to me in a story. So here's the story that we're going to graph. Chloe leaves home driving at a speed of 30 miles an hour. She drives at this speed for 8 minutes, stops at a red light for 2 minutes, and then drives at 30 miles an hour for 10 more minutes until she arrives at work. So this is a very common situation. You could imagine that you're Chloe, and we're going to track her progress on a graph. So the first thing we need to do is draw a graph. And we can do first quadrant only because this is, it has the 0, 0 condition, and I'll show you that in just a second. So I'm going to just sketch the first quadrant of a graph, and we will label our variables and all of that good stuff. So here is the graph. And they give me the ratio of miles per hour. So they're telling us how to set the graph up. This will be miles, and this will be hours. Now I am going to work with the hours just a little bit because it doesn't take her an hour to get to work. Let's look at the driving times. I'm not going to just assume that you're following me. She drives for 8 minutes, stops at a red light for 2 minutes, and then 10 more minutes to work. So 8 plus 2 is 10, and 10 more is 20 minutes. So even though the ratio is miles to hours, I don't want hours. I want to make my independent my independent variable be in terms of minutes. And since I don't have enough room to do 1, 2, 3, and so on, I'm going to graph this by 2's. So here's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and I'm going to go one more to 22. Now we know that that's as far as we need to go because she only traveled for 20 minutes. And then on the miles, I'm going to do the same thing. I'm going to let this be 0. And here's 2, 4, 6, 8, 10 miles. 12, 14, 16, 18, 20 miles. 22, 24, 26, 28, 30 miles. 32, 34, 36, 38. And you might be wondering why I haven't labeled each of those tick marks, and you certainly can do that. This is just a habit I developed in school so that I would not get the axes confused. Sometimes if they look exactly the same, I forget which one I'm graphing. So I would make my minutes look one way and my miles look another way, and I could tell the difference. But you certainly do not have to do that. Erase that line. That's kind of bugging me there. Okay, so here we go. I told you a minute ago that this satisfies the 0, 0 condition because at home she has gone 0 minutes and 0 miles. All right, it tells us that she drives for 8 minutes at 30 miles an hour. Okay, so at 8 minutes, how many miles would she have gone? Now that's a question we're going to have to answer. X is minutes, Y is miles. Now, let's use what we've learned about graphs to come up with our intercepts. Actually, we don't even have to do that. We've already got our intercept. The intercept is 0, 0, because when 0 minutes have passed, 0 miles have been covered. So we already know our y-intercept. We need to know, let me think how best to do this. We eventually want to know the increasing and decreasing intervals, or the increasing interval. Okay, I am not going to make this harder than it needs to be. Let's look at those first 8 minutes. All right, so the first 8 minutes, I'm going to call the first section of her journey. That's when she had driven 8 minutes, and we need to know where she would be at that point. All right. Now, if we knew the unit rate, this would be an easy thing to figure out, but we don't. So let's, we could figure it out. Let me think how best to do it. I think I'm just going to use ratio and proportion. All right, so we know that she is traveling 30 miles in 60 minutes. Remember, we're doing miles and minutes. So 30 miles in 60 minutes. How far could she travel in 1 minute? Let's do it that way. So we could say 30 times 1 is 30, and then 30 divided by 60 is 1/2. So she goes a half a mile every minute. That's the unit rate right there. If they had asked you to find a unit rate of miles to minutes, that would be the one. But that still doesn't answer my question about the first section of her journey. So let's do it again. Let's say that miles to minutes, and I'm just going to use 30 miles to 60 minutes, but you could use the unit rate if you wanted, because everything's equal. I want to know how far she can go in 8 minutes. So I would do 30 times 8, that's 240. Divide by 60 is going to be 4. So when you have 8 minutes, you have 4 miles. And that's that first point. Let me bring this up here so you can see where I got that right there. And I'll bring this somewhere else because we don't really need it. All right, so here's the 8 minutes, and we got a 4 out of there. So this part is coming from this math. Okay. All right. Trying to get all this to fit here. So 8, 4, that's going to be the first point that I plot. So I go over to 8 minutes, and I go up to 4 miles, and I drop a point. So this was that first leg of her journey where she drove to the red light. All right. Then she sits for 2 minutes at the red light. So that would be from, I'm going too far. That would be from 8 to 10. She just sits there at the red light, not moving at all. Okay. And then what does she do? When the light turns green, she starts driving again, and she drives for another 10 minutes. So this is the second section. Okay, so we need a point. And this is a little tricky. She's going to be driving from 10, the point 10, for 10 minutes. So where would that put her? If she starts at 10, because that's when the light turns green, and drives for 10 more, she will be at 20 minutes. So we want to know how many miles that would be. So let's try setting up our miles to minutes again. So we're going to say that she drives 30 miles an hour. Now be careful. We don't want to have her driving in that blue interval, because remember, she's sitting still. We just want to know from 10 minutes to 20 minutes. So that is 10 minutes that she's actually driving. So we'll say 30 times 10, that's 300, divided by 60 is going to be 5. So that's going to be 5 more miles that she covered. So be careful, the slope is going to change here. It's not a constant slope like we're used to. So at 20 minutes, she has gone 5 more miles. So we're going to say at 20 minutes, she is at, be careful, it's not 5 miles. You have to add it. It's 5 more miles. So let me highlight that. 10 more. So what are we going to add it to? When she stopped at the red light, she was at 4 miles. I know this is hard for some folks to see. It's a tough problem. When the light turned green, she was still only 4 miles into her journey. So we're going to add 5 to that. 5 plus 4 is 9. So at 20 minutes, she has traveled 9 miles. And that'll be between lines, because that is, they're scaled by 2s. So that's the graph we're looking for. This is 20 minutes, and she's 9 miles from home. So we have increasing intervals, but we also have that time that she's at the red light. All right. So we can say, let me highlight. Here's an increasing interval. Here's an increasing interval. But this interval is not increasing. That interval is constant. So if they ask you for increasing intervals, you could say this. When x is between 0 minutes and 8 minutes, there's an increasing interval. And when x is between 10 and 20 minutes, there's an increasing interval. But we cannot count. Let me say it this way. This is a constant interval. When x is between 8 and 10. Okay. So you can't just say that from 0 to 20 minutes is an increasing interval, because it isn't. There was that period of time when she was sitting still. And you see how that interrupted the slope. I can't use rise over run like I can in a graph where the slope is constant. So we would say that this slope is not constant. Okay, let me see if there's anything else that I need to say there. That is not an easy question to graph, in my opinion. I hope you find it easier. But I believe that's all I can do on that one. That's all we need to do, because we have done what we were supposed to.